Solving absolute value equations. So when you take the absolute value of something, you're actually determining the distance away from zero. It doesn't matter if you move left or right to get to that number, so the sign is not important. The direction you're moving is not important. What's important is how far that you move. So for example, when we take the absolute value of 6, we end up with a 6, and that's because 6 is 6 units away from zero. And the same kind of idea happens when we take the absolute value of -6. -6 does move left from zero, but we don't really care about that with the absolute value. I just want distance. So yes, we're moving to the left, but we're moving left 6 times. So the absolute value of -6 is also a 6. That is why we do not take positives and turn them negative. We only take negatives and turn them positive because you're counting distance away from zero. So if we use that, if we know that the absolute value of x is equal to 5, well, then what values of x am I allowed to have? Well, what numbers in here will be 5 away from 0? Well, that can be a 5, or it can be a -5. So there's actually two solutions to this absolute value equation. There's not always two, but there can be at most two. And these are true because they're both 5 units away from 0. So let's take that and put it into practice. So solving absolute value equations. The first step to solve these is to make sure the absolute value is isolated. Get the absolute value alone. So you're kind of solving twice. You're solving once for the absolute value, and then you solve again for the variable itself. So if you look at number 1, this actually has the absolute value isolated already. There is nothing else on this side except for whatever is inside the absolute value. So step 1 is completed. Step 1 is already done. Step 2 is now we're going to actually basically take the absolute value is basically what we're going to do. We're going to split it into two smaller equations. So if the absolute value of r plus 4 is equal to 1, that means whatever is inside, whatever r plus 4 is, has to be 1 away from 0. So what that means is that means that r plus 4 can either be equal to 1 or r plus 4 can be equal to -1 by using the same logic process that we used up here. So this inside has to be 1 away from 0. And so the two numbers that are 1 away is 1 and -1. Now that you've taken the absolute value, we need to actually finish off solving. That's step 3. Once you've split it apart, solve the remaining equations individually. So if I want r by itself, I'm going to subtract 4. And so we end up with a solution of r equals -3. There's one solution. If I want r over here by itself, we're going to subtract 4 as well, but we get a different answer. -1 minus 4 is -5. So don't assume just because this is -3, this is not +3, or the other way around. If this was +3, that doesn't mean this is -3. Okay, the numbers can be different. Let's look at number 2. What value of m makes the absolute value equation below true? So for step 1, you're supposed to isolate the absolute value. So we need to get this absolute value by itself. So imagine this is just one giant variable. Pretend like this is just x. If this said -2x plus 5, what would you move first? We would have to take away the addition. Same solving process. So get rid of the plus 5. So we have -2 times the absolute value of 2m plus 10 equals, and then -27 minus 5 makes -32. Now that the addition subtraction is taken care of, again, we want this piece here all by itself. So we're going to solve for this, which means I have to divide out the -2 in the front. That's being multiplied. So the -2 is going to be divided out. So we end up with absolute value of -2m plus 10 equals -32 over 2 makes a positive 16. Now the absolute value is completely alone. We can actually perform the absolute value. So that means this is going to split into two smaller equations. The first one takes whatever's inside, -2m plus 10, and sets it equal to the positive version of the right-hand side. So the stuff inside is 16 away from 0, or the stuff inside, -2m plus 10, could also be -16, because -16 is also 16 away from 0. So it's always the stuff on the inside equal to the positive, and the stuff on the inside equaling to the negative version of whatever is out here. Now that you have the smaller equations, go solve them individually. So solve the left one until you have m alone. So we're going to subtract 10 from both sides. So negative 2m equals 6. Divide out negative 2. And we have m is equal to negative 3. So there's one solution. And then over on the right, subtract 10. And you notice we have something different. Negative 2m equals a negative 26. Divide by negative 2. And m will equal a positive 13. So my two solutions here are negative 3 and 13. Let's look at 3. So for 3, same idea. Take a minute, pause the video, get this absolute value isolated first, and then unpause and see if you're correct before you move on. So with this absolute value, we're going to have to subtract 2 first, get minus 3 or negative 3 times the absolute value of 3 over 7x minus 9 equals 16 minus 2 makes 14. Finally, we're going to have to divide out the negative 3 to get the negative 3 away. Absolute value of 3 over 7x minus 9 is equal to a negative 14 thirds. Now pause here and think for a second. The absolute value is supposed to count distance from 0, not caring if it's positive or negative. Well, that means you'll never end up with a negative number. So when you take the absolute value of something, you should never equal a negative number as an output. It takes negatives and turns them positive, and it takes positive and turns them more positive. So the fact that we have an absolute value by itself equaling to a negative number, this equation has no solution because that will never happen. You will never have the absolute value of a number equaling something that is negative. That is never something that is going to work. So the moment you see this happen, you're done. The answer to this equation is that there is no solution to this. Next section, let's talk about extraneous solutions. So what an extraneous solution is an apparent solution that has to be rejected because it does not satisfy the original equation. Now, I haven't mentioned these before, and there's a reason for that. The other examples don't have them. This happens when there is an x on both sides of the equal sign, or there are two sets of absolute values. The other examples never had that. There was one variable and one absolute value. So if we look at number 4 has an x on the inside and an x on the outside. So there could possibly be one of those extraneous solutions going on for number 4. So let's see. We're going to solve it just like normal. So this has the absolute value already isolated. So we are ready to split this into its two equations. So the first equation is going to be the inside, 4x plus 10, equal to the positive version of the right, so 6x. The second equation is the inside, 4x plus 10, equaling to the negative version of the outside. Make sure you put parentheses around it to make sure you don't miss something. For this case, though, you don't really need the parentheses because if you do negative of 6x, well, you still get just a plain negative 6x. So we can actually not worry about the parentheses for this one. And now we're going to solve both of these like normal. So I'm going to subtract. And now we're going to solve both of these like normal. So I'm going to move the 4x over because you got to get your x's together first. So move your 4x to the right. And we get 10 equals 2x. And then divide out the 2. So our first possible solution is 5. Don't box that yet because that may not be correct. Let's solve the left-hand one. I'm going to subtract 4x again. And we get 10 equals negative 10x. Divide out negative 10. And again, another possible solution is x equals negative 1. So we have to check and make sure these are actually true. So the way we do that is we plug them back in. So that's the last step for these, is you have to check for extraneous solutions. That's the last piece. So what that means is I'm going to put a little check mark and I'm going to check x equals 5. That's what I'm going to do. And that means I'm going to plug it back in. So absolute value of 4 times 5 plus 10 hopefully equals the 6 times 5. Plug in your number in back where you see x and simplify. 4 times 5 makes 20, and 20 plus 10 makes 30. 6 times 5 makes 30. The absolute value of 30 is 30. Well, 30 equals itself, so yes, this is true, which means x equals 5 is a solution. Now we're going to do the same thing. We're going to check x equals -1. We're going to plug that in. So we've got absolute value of 4 times -1 plus 10 equals 6 times -1. So now let's see. 4 times -1 is -4 plus 10 makes 6 equals 6 times 1 is -6. So the absolute value of 6 is 6. Does that equal to -6? No, it does not. So because this came out with a false answer, this right here is not a solution. You're not allowed to have x equals -1 as a solution. So our only answer to number 4 is x equals 5. That is the only x value that makes this equation true. I'm going to help you start on 5, and I want you to finish it off on your own. So for number 5, we first have to isolate this absolute value. We need to get this guy by itself. So we're going to divide out the -4 from everything on the other side. The -4's make a 1, so we have absolute value of 2x plus 3 equals -12x minus 4 makes a positive 3x. -8 minus 4 makes positive 2. Now that we have the absolute value alone, we can basically perform the absolute value. The inside has to be 3x plus 2 away from 0. So we're going to take the inside, 2x plus 3, equal to the positive version of the right-hand side. And we're also going to take the inside, 2x plus 3, equaling to the negative version. Here's where you have to have your parentheses. And you need your parentheses because it's negative of all of this, not just the 3x. It's negative of the entire 3x minus 2. Sorry, 3x plus 2. So we need the negative with parentheses to tell us that I need to distribute out this negative to both. Pause the video, see if you can solve both of these, and check and see if you come up with any extraneous solutions. So we should have had x equals 1 is a solution because when you substitute it back in, you'd get a true statement. So this worked as a solution. X equals -1 did not work as a solution because when I plugged it back in, it gave me a false answer. Just because they're negative, though, doesn't mean they're always not solutions. You can very well have negative solutions. If we look at example 2, for example, we had a -3. That's okay. Negatives are fine. So for number 6, what is the value of x that makes the equation below true? So for this one, we've got two absolute values equal to each other. The process doesn't change, though. So we're still going to take this inside, so the x plus 5 on the inside of one of them will equal to the positive version of the other one, or the same thing, the inside of this will equal to the negative version of the other one. So nothing really changes even though you've got two absolute values. What changes is that when you're solving, sometimes something crazy will happen. So if I try to solve the one on the left, I'm going to take x and subtract it from both sides. And we get x minus x, which also makes 0. So we end up with 5 equaling to 11. So what happens is our variables canceled on this side, and so this little bitty equation actually has no solution. There's nothing for us to use off of this equation. So this equation basically yielded us nothing. So now we have to try this one. Maybe this one will give us something. So I'm going to distribute the -1. So we're going to end up with x plus 5 equals -x minus 11. I'm going to add x to both sides to try to solve. And look, I do end up with 2 x's this time. So now I'm going to have a solution. So that's good. Subtract 5 from both sides. And we get 2x equals -16. Divide out the 2. And we get x is equal to -8. Now, just because this is the only solution doesn't necessarily mean that it's true. So we still do have to go through the checking process. So we're going to check x equals -8. So we're going to substitute -8 plus 5. And the absolute value is equal to the absolute value of -8 plus 11. So we get absolute value of -3 equals absolute value of +3. Well, let's see. So the absolute value of a -3 is a +3, and the absolute value of a 3 is also +3. So yes, this is true. This does in fact give a solution. However, if this had come up false, that means there was no solution here, and this wasn't a solution, so the entire equation would then have had no solution. So if you end up with either both of these turning out false or there's no solution, then you've got no solution as your answer. So take a minute, try and see if you can figure out number 7. Pause the video. So for number 7, you should have had x equals 8 as a solution and x equals -2 as a solution. So for number 7, there were no extraneous solutions in this case. And that's okay. You don't always have to reject something. So isolate the absolute value, split it apart into two equations. So isolate, split, solve, and then check and see if they're going to make a true statement.